Hello, this video is mainly centered around the challenge Pommerman, which is a very famous global challenge in reinforcement learning. So I'll walk over the contents of the video before I dive in. First of all, it will have a very brief description about the challenge Pommerman, and then how to go about participating in Pommerman and how to set up the environment and stuff. Just a brief description of the resources, and then the models which have been used for comparisons and the best model which came out of it. After that, we have a small explanation of a very basic code so that the beginners can get a basic understanding of it. Now again, this video is aimed for beginners, so I won't go into very exhaustive details about how everything works and how stuff happens. But then again, I'll give you links. If you are interested, you can go and explore that. And if you want me to upload another video with more detailed descriptions and explanations, let me know in the comments. Alright, so what is Pommerman and where you can find it? So you can find Pommerman here at pommerman.com, where I've highlighted. Links in the description below. So Pommerman is basically a variation of Bomberman, and we will be playing in this. So here the rules are like there are 4 agents. There are 3 power-ups which are given to you, certain rules like there are wooden walls, there are impassable passageways, passable passageways, and then you have to be, we will be focusing on FFA. In FFA, basically, you have to be the last one standing. More on this. So you can explore it for more details about the challenge. Now, how to get started on the challenge? There is this GitHub repo. Again, the link is in the description below. Here, you will be given the basic setup environment and the basic FFA, simple agent FFA.py. Now, that FFA.py is the basic agent which has been provided by the challenge creators, which you can use to simulate in your system just to check whether it's working or not. The setup is very important because you'll be basically running it in your terminals and stuff, so you need to know, you need to set up the environment, you need to know how it works. You have to explore it a bit. And this is the playground. Again, as I mentioned, we'll be focusing on FFA. Now more on FFA. FFA is more on a multi-agent environment system, and it is also on the 11 by 11 grid like the other variations, including team and team radio. In it, we have 4 players, all right, where the last one standing wins the game. So there are 2 ways. Either you maximize the time for your agents living, but then again, there's the catch that you have to take care of the other agents also. If you're just trying to stay in one position, trying to maintain your agent alive, it's tough to win the game. I will explain why this method does not work. So basically, you have to learn to kill the other agents also here so that you can be the last person standing or the last agent standing. Now again, the reasons for participating, how you can train your agents, how to submit your agents, who is contributing, the code of conduct and the citations and stuff. Again, you can explore. I have put the link in the description. For any doubts or anything, you can let me know in the comments. So for this, I have there is a detailed explanation in this blog which has been created. So if you want to dive into the details before commenting, please read this blog. It's a very earnest request. Now I will walk you over through the basics of the blog. This blog is a basic overview about what is it and how it goes about. So then again, it is about the multi-agent reinforcement learning. So why multi-agent reinforcement learning? See, in multi-agent reinforcement learning, we have multiple agents interacting with each other. It can be cooperative or it can be competitive. So here we are in the second line. We are in the competitive range, and we need to model the multiple participants such as that we kill the other ones so that we can win. Talking about the variation of FFA, there are many strategies which can be followed. I'll just be coming to it in a minute. So there are a lot of problems of the MARL agents, as there is a lot of benefits, there's a lot of cons also. In practicality, there's a curse of dimensionality, training, and ambiguity. Again, for details, you can refer to the blog. So these are the rules for actually working on the Pommerman environment. There is up, left, down, right, bomb. There are 3 power-ups. There are wooden walls which can be passed and which cannot be passed depending whether it has been blown or not. There's the board type, the position, And then you'll be given ammos. The ammos, if you're able to blow up properly, you will be rewarded with 1 ammo. Otherwise, you might even be killed by an ammo, which the other agent might plant for FII. And then there's the blast strength of the ammo, whether it can kick or not, how your teammate is doing, whether it's not, the teammate part is not considerable to us since we are only working on FFA. Now the enemies and the bomb blast strength and the bomb life, again, all of this you can just read about it. So now all of the policies which have been used in this block, the methods which have been compared here are PPO, A3C, DDPG, DQFT imitation learning. So the one which stood out the most was DQFT. So the code is here. I have included snapshots and the code, the link to the code also. So if you click here, you can go, and anyways, the link is there in the description. So I've already opened it here. I'm repeating it again that this is a video aimed for beginners. So I will just be explaining briefly about what the code does, why it does so. And if you need a more exhaustive versions of this code and everything, you can go and explore GitHub first. There is a code of Skynet, Borealis, I don't know, Borealis AI, which won the competition in 2018 for Pommerman. The competition is still live. It will, and then you can participate in it again. So these are the libraries which need to be installed: Keras, TensorFlow, Scalon, Matplotlib, basics, right? And then this is just the configuration. Now this is the loaded data set. So firstly, I'll explain a little bit about the DQFT, why it worked better than the other optimization algorithms. So in normal traditional reinforcement learning methods, we had Monte Carlo, TD Lambda, Q learning, but all of this, when given into the practical environments, doesn't work that much, especially in our scenario, because we do not the Q learning and all the, it is very, very huge and very, very complicated, and this is a complicated environment. All right, we have 11 by 11 grid and multiple rules to consider. Like I just ran through the rules, right? There are kick, there is ammo, there is blast strength, a lot of things which cannot be handled by the traditional RL methods. So we moved on to PPU, DTPG, A3C, imitation learning, and now in PPU and all of that, we give a little supervised taste to it. So we have let's say an Oracle, which are the trained demonstrations of the Pommerman, like here, and then we run a deep learning model on that in DQN basically, and then the model learns, the DQN model learns how to navigate through the environment. It is now, DQN is mainly computationally very inexpensive, and it has some other benefits also. Now focusing on DQFT again. So DQFT stands for Deep Q Learning from Demonstrations Agent. The DQFT agent here learns from the experience of the rule-based agent, which in comparison to the previous agents, as mentioned earlier, it explores significantly more. What I mean by this is that the other agents were just learning how to stagnate in one point, maximize the time, as I mentioned, right? But that doesn't work. That doesn't work. You can't live long just by sitting there, because some other agent will come and kill you, since you have to compete with the other agents. In the actual gaming environment scenario, those four other agents will be some other people's agents. If they know how to kill, you're dead. So they don't work as well. The bottom line is that. So, but in DQFT, your agent actually learns to interact with the environment and starts moving around and starts exploring the ammos and, you know, the walls and the properties which is there. So that was the basic overview for DQFT. Now again, this is the data set which we are using, this one. So you can load this. This has three things: observation, actions, and rewards. We'll put it out. So firstly, the observations, the X, which we will be mainly working upon. The observation is what we will be feeding our models, right? So it is X. Now we have P and V. The P is the policy, V is the value. All right. So we will give it an X, and it needs to output a policy and a value. Like what is the maximum reward and what is the best optimized way of achieving it. So this is for the training data set. Now you can see that the training data set has 600,000 examples, and it is based on an 11 by 11 grids. All right. And then there is the testing data set here, which has around 80,000 examples. Now coming to the neural network part, if I did not mention it clearly before, this data set has the Oracle learned, like that is the Q learning and all the stuff which is required. I mean, the basic learned demonstrations on which this model will run. So now in this model, we have the input shape of 11, 11, 18. Since you can see, we have the shape here as 11, 11, 18. All right. Now then we have three convolution filters which are stacked on top of each other. The X goes into this first convolution filter, and then this convolution filter goes into the next and into the next. Okay. And then finally we flatten it out, and then we are expecting two outputs, right, as we mentioned earlier. That is the p value and the v value, the policy and the value. The policy is defined with this. This is just the basic hyperparameters, and the value is defined like this. Now when we are defining the model, see, this is X is the input and P and V is the policy and value pairs in a list, because we can only output a single value. We are outputting a single value here. Please note that. And then we compile the model. So as you can see, this is the description of the model. So we have three convolution layers, then it has been flattened, and then we have the P and V values at outputs. All right. So moving on to the next part. So we call the model. Obviously, we train the model, we fit the model, and these are, I've just shown one epoch. As you can see, you can run it more if you want. This just shows the basic parameters about how it is learning it all. This is just because this is a demo video again. So now these are the comparisons of the prediction accuracy and the mean squared errors. Now again, there are certain experimentations which have already been performed. So the first model is this one. Now there is we predict the pre-trained, pred, by-trained, pred. Now please don't be confused by this. These predictions are just for plotting the graphs and just for getting an idea how these metrics are coming. So we predict it giving the X values like the X train and X test, and we can define the batch size. You can change the batch size as possible. Try to keep it in powers of 2. That's good for the system and good for your speed. Good for you also. So these are the metrics which are here. Yeah, so this is the basic explanation and overview of the code, blog, and the links and resources. If you want to explore more, let me know. If you want more resources, let me know. I will post another video if required, and if thank you for watching.